So next, Ibu Bapak from Olivia Bunga Pongtuluran and Amalia Suzianti. It's about the use of response surface method, okay, to optimize the ultrasound-assisted extraction of Moringa leaves. So time and session is yours, Ibu Olivia. There you are.
Yes, of course.
Yes, please. You may start.
Can you see my screen?
Yes.
Wait a minute. Okay. Hello, everybody. Before we begin, let me introduce myself. I'm Olivia Bunga, and I'm a graduate student at Universitas Indonesia. Today, I'm going to be talking about my research entitled The Use of Response Surface Method to Optimize the Ultrasound-assisted Extraction of Moringa leaves. The ultrasound-assisted extraction is one of the breakthrough in extraction techniques because the equipment used are simpler and easier to perform, as well as saving energy and time efficiency. The object of this research is Moringa plant. Moringa plant, or in Indonesia we know very well known as kelor, considered to be one of the most nutritious plants, and all parts of the plants can be utilized, such as leaves, flowers, fruits, and seeds. The Moringa plants have some pharmacological effects as wound healing, anti-anemia, anti-inflammatory, antipyretic, analgesic, and antimicrobial. The background of this research are, first, people have been using traditional medicine since old time as an effort to maintain health, prevent disease, and healthcare. And the second, the variety of medicinal plants in Indonesia is gift that needs to be maintained and utilized optimally for the development of traditional medicinal products. And the third, the most people in Indonesia believe that consuming traditional medicine is relatively safer than conventional medicine. In addition, raw materials and products are cheaper and easier to obtain. Data published by Ministry of Trade in 2017 shows that people in China is the largest in using herbal medicine, followed by Japan, Chile, and Canada. In Indonesia, about half of the population consume natural or herbal medicine, and it is well known here as jamu. So the purpose of this research are to investigate the effect of ultrasound-assisted extraction time, solvent to solid ratio, and ethanol concentration of moringa leaves, and their impact on the yield, total phenolic compound, and total flavonoid by applying RSM, or response surface method. Moringa sample used in this study purchased from a traditional market. Samples moringa sorted by separating the stems and branches that are large enough, washed thoroughly and dried in the sun for 3 days to a maximum of 10% of water content, then finally ground with a grinder. The sample is then stored at room temperature in a tightly closed container. On the flowchart, we can see that the moringa leaves first washed, dry, and grained until powder form, then extracted using ultrasonic probe for 10, 20, and 30 minutes. After that, the solid and liquid paste are separated using filter paper, and the liquid paste then evaporated at 50 degrees in a pressured rotavapor until the thick extract obtained. The extract then analyzed to know the amount of yield, total phenolic content, and total flavonoid. For the experimental design with response surface method, RSM has been effectively implemented for the optimization of condition in pharmaceutical and food research. The central composite design, or CCD, of the RSM was used in this research as one factor at time technique is time consuming and neglects the interaction of some complex factors. In this research, Minitab 16 was used for optimization. The factor time has three levels. Those are 10, 20, and 30. And the solvent to solid ratio is 25, 50, and 75. And the alcohol concentration also has three levels. Those are 50, 73, and 96. The experimental design of this research employed 40 runs of RSM constructed by central composite design. The output showed that the percentage of yield about 0.37 until 9.86%. The total phenolic compound ranged from 27 to 59 milligram gallic acid per milli, and the total flavonoid varied from 5.5 to 67 milligram per milli. For the response of yield, as can be seen from the equation, the factor of time showing no significant effect on the yield. The figure proves that the surface plot for 10, 20, and 30 minutes present the same model. Parameters that affected yield are solvent to solid ratio and the alcohol concentration, and the lack of it for this model is 2.08, and the probability is smaller than 0.05, and the R square is 0.95. For the response of the total phenolic compound, the factor time and solvent to solid ratio do not show any significant effect. Parameters that affected only ethanol concentration. The lack of it for this model is 24.36. The probability is smaller than 0.05, and the R square is 0.66. For the equation and the response surface of total flavonoid, we can conclude that the solvent to solid ratio and ethanol concentration influencing the total flavonoid, but the time proving no effect at all. The lack of it for this model is 130. The probability is smaller than 0.05, and the R square is 0.91, means the model is good.
No effect ya, Bu?
Yeah. For the conclusion, the more ethanol concentration used, the more phenolic and flavonoid content generated. However, the yield production decreased. On the other hand, the higher the solvent to solid ratio creates the high yield, yet this variable showing no impact toward two other responses. The result of this study revealed that extraction time has no effect on all the responses. For my future research in the future, the time spent in the extraction process should be longer to better understand the extent of the effect of the time on the result. And the second, this research can contribute to the following steps of Moringa in producing yield and evaluating the bioactive compound with the advantage of shorter extraction time and minimize solvent use. This is the end of my presentation. Thank you for your attention.
Thank you so much, Ibu Olivia. Can you go back, Ibu, to that previous slide page? Okay, thank you so much, Ibu Olivia, for your presentation regarding Moringa leaves, ya, Ibu ya. And then you try to optimize with ultrasound technology. Yeah. Any question from the floor? Oh, no. Okay. No question from the floor. Pak Amin, sorry, we skip or we miss, ya. I miss your question for Mbak Ajeng. I'm so sorry, Pak Amin. So for your session, Ibu Olivia, my basic or simple question, ya, Ibu, regarding Moringa leaf. Why in your study you want to try like to optimize with the technology, with the ultrasound technology? What happens before with the current Moringa leaves?
All right. Actually, in the industrial herbal medicine, nowadays they use extraction process, namely percolation or maceration. It is very time consuming and consume a lot of energy. With this ultrasound method, we can cut the time, and also we can get more result, as well as saving energy, and of course time, money.
With better result, Bu. With better result with ultrasound technology.
Yes.
Okay. Do we have to use ultrasound technology, Bu, to cut the time, to speed up the process?
Actually, if we use the solvent, we can, I mean, if we use the right solvent for the extraction process, which is suitable with this method, of course, we will get more better efficiency in terms of extraction process. But if we use maybe solvent that is very harmful for environment, I think so. It's depend on the choosing the solvent and also the materials that we want to extract.
Okay. What are you gonna say or suggest to the next researcher for those who want to continue your investigation deeper with ultrasound technology? What are you gonna say, like, do they have to add another technique, or do they have to be careful with the composition or the portion of something in the process?
All right. Because this method is actually not really a new method. It's maybe about 5 years ago, some industry outside have applied this process. But the bad things of this process is the sound of the extraction machine is a very bad to our hearing. So maybe they have to overcome that problem. Yes.
Is it feasible to have or to buy the technology for many people, for many researchers in this area?
Yeah, I think so. But I see in some industrial or industry jamu in Indonesia, it is rare because they have to be educated about how to use these techniques first, because they always do the same things. I mean, the same process, the same method. So it is not easy to encourage them to a new technology. Yeah.
Okay. One more question, Ibu Olivia. Ultrasound technology, yeah, we know that it's a technology. My question is it like the affecting the pure ingredients or the real benefit of moringa leaf, like becomes destroy or becomes minimize or break the ingredients, so the moringa leaves will not be giving good benefit as it is actually.
So the process is like this. Before we started the extraction process with the ultrasound, first we have to grind. We grind first the materials until maybe about in micro size, and then we put it in a container and add some solvent in it for about maybe minimum 10 minutes. Then the substances of the things that we want, which is trapped in the Moringa leaves will be exploded. I mean, will be come out slowly. That's how the extraction process, the extraction of ultrasound process work.
Okay, thank you so much, Ibu Olivia. I think our time is up, yeah, 14:50. Thank you, Ibu Olivia, for your presentation.
Thank you very much.
My pleasure, Ibu Olivia.